Right. Yeah, so people used to call me Mehdio online. So some disclaimer before starting. I'm not going to talk about data stack. I know in the previous presentation you had a stack, but so no modern data stack BS. And there is more memes in GIF in this presentation than slides, so don't be shocked. But I think there was some pretty good level with the previous presentation, so that's fine. So a little bit about me. So I'm Belgian, but I've been living in Berlin for the past 3 years. I've been working for the past 8 years as data engineer, and so recently as staff data engineer. So not sure if you're comfortable with staff. It's basically just on the technical track. People come to see me when they have a technical problem with their project, not when they want a salary raise. I've been working for the past 4 years in hypergrowth environments, so Klarna, back market, and recently, so I'm working full-time at Trade Republic. And I actively create data tech content online, mostly around data engineering, under Mehdio, YouTube, LinkedIn, Medium. You have all the links on med.io. And I also launched datacreators.club, which is a website where you can find data creators no matter their content, data science, machine learning, data engineering, and their channels. So YouTube, Medium, Twitter, LinkedIn, pick your first flavor. And I also have a podcast with those people. So yeah, a lot of stuff. I play too much League of Legends in my free time, and I'm a husband and father, and this is my beautiful family with a GDPR-compliant picture. So if by now you're asking yourself how the hell I'm doing everything, well, I just have a cloning machine. But the reality is that I've been struggling a lot to be consistent. But one easy thing to do, if you like this presentation, is to subscribe to my YouTube channel. I love doing that in real time because in the video, people can just skip the video, but you cannot, yeah, you can escape the room, that's true. Anyhow, so what's an hypergrowth? But it's simply, here you have the different phase of a company, and you see the growth part, and basically it's a company that has achieved a lot, had some success, and is ready to take to the next level. So they have a product market fit. They may have some revenues. There is a difference between growth and scale. And basically, usually a growth really implies a growth of resource, while scale usually increase revenues with less increase of resource. So there is more stability through the mature position. And those companies usually had a big funding round to reach basically the next level. And the point of attention here is that you see that time is really, really short. So let's say you have a 300 people company and you are in hypergrowth mode, that probably you're gonna double the size in 1 year, right? So it's like 25 people coming each month, right? And so we're gonna talk about the challenge of such a situation. But anyway, the challenge I'm going to talk here is also not for only hypergrowth company in data. Unless you've been living outside Earth, hiring data profile is hard. And especially in hypergrowth company, you have the current data guy, which is basically need to do also the technical interview for the new folks. You have hiring manager, a really small talent acquisition pool, a lot of candidates in pipe, and new hire which are struggling with the onboarding process. Fact number 2 is that 1 year in a hypergrowth company is 1 dog year. Does anyone knows how many human years is a dog year? Yeah, like 7 to 15 even, depending on the breed. So yeah, like let's keep it like 15, but it makes sense, right? In my example with 300 people company, at the end of the year, 600 people. I mean, you need department, you need to change culture on different things. So it's really a different company. Fact number 3 is that data is at the center of everything. So if you consider the different teams, you have product teams, which is basically over there, and the data team is more horizontal. So it's really at the middle of that huge spaghetti bowl, right? And that makes the thing even more challenging. All right, let me tell you about a story about Bob, the Bob incident. So this is Bob, and AKA the F.show. I promise this is the only one line of code that there is in the slide. so no worries. Does anyone knows actually what is it doing? Yeah?
I believe that's PySpark, and that's showing part of the...
Yeah, cool, yeah. So that's Apache Spark. Basically, it's showing the data frame, the data, it's a method, okay? How many people are comfortable with Apache Spark here? Okay, a few. Yeah, let me quickly introduce Apache Spark. At least you get that for today in a really simple way. So Apache Spark is a data processing framework that enables you to distribute your code against a cluster of machines. Wow. So if I have a book, let's say, to read, and I want to count the number of words in that book, okay? As a one person, one machine, it's going to take me time to count the number, the words of that book, okay? But if I distribute my code against some workers, let's say, lady over there and the person over there, and I give like half of the book to both of them, and each person is going to basically count the number of words on each part of the book, and as a job manager or the driver, that's a Spark term, I will just have to sum the intermediate result, right? So I distribute the code, and of course, it's faster because I have more workers to do the job. The problem with df.show is that it's just printing actually a data frame. It's not doing anything. It's not transforming any data. It's just printing the thing. If you leave that in production, that's actually inefficient. It's like asking our workers over there to scream every number, every count that they do, which is useless. I don't do anything with that. I just want the result, okay? So let's look at Bob's data pipeline stats. So every hour, he runs an incremental data pipeline job. The time is 10 minutes. So the price per job is 22 cents. So 158 euro per month. And if he has 10 data pipeline, basically, it's 1,580 euro per month. And by the way, this is realistic numbers. If you want to run an Apache Spark pipeline hourly with like quite some decent data, not too small, not huge, it's realistic numbers. So now if I remove that line of code, which is not doing anything, as I explained before, then the job is taking 6 minutes. The price per job is 0.132 cents, and then 95 euro per month, and for 10 data pipeline, 950 euro per month. And so yeah, I'm saving 630 euro per month. The pipeline is cheaper. So question is, how can we avoid this situation with Bob and such a bad pattern? It's an open question. Do you have any idea?
Code quality checks,
Yeah, no it's sharing. So the thing is, who would fire Bob? No one, right? Because we feel that like it might be not Bob's fault. So let me tell you the backstory about here. So Bob is actually a new hire, and he just mostly take basically the data from the OG data guy, which was already there, which is just firefighting to keep the request. And why is he firefighting? It's because he has business screaming at his desk that he needs things for yesterday. And why the business is screaming? Well, if you remind the first slide, we have huge funding. So we have a VC, which is asking, where is my money? And that's not the worst part. There is more Bob. By the way, this is a figure of speech. I'm not Bob in the story. At least that's what I want you to believe. So more Bob that copy-paste code with a bad pattern. And if you do the math, that's almost 2,000 euro per month lost for a single line of code. Okay? So the point is, every small problem can be a big problem at scale. Thank you, Mehdio. That's obvious. But yeah, please remember, if you look back at the graph, the time is really, really short. And that makes the thing challenging, is that this line of code that you leave there, it's like, it's not going to hurt. You have 25 more Bob coming each month, right? If you take back the example of a 300 company that is in hypergrowth, so that's huge. So again, how can we avoid this? Well, the baseline is basically know your data and your TCO, so total cost of ownership, and adopt FinOps mindset from day one. So cloud can be really expensive when you used to have on-premise cluster and if you run a big resource job, you're just bothering others' resource, right? now you're not bothering anyone except the finance department because your credit card is burning, right? So it's easy on a cloud to put budget alert, please do so. But you need to go a step further. So usually when I get into a new data stack, I ask, okay, how big my data are? What are the biggest data assets? How fast are we computing the data? So is it daily? Is it hourly? Do you have streaming data pipeline? What's the growth of the data usage, both in terms of storage and compute? What's the growth of the use case? So when you get that, then a last interesting point is that how important my data is. So let's say you have the 5 most expensive data asset or 5 compute job that is the most expensive. Are they really relevant for the business? Can we just refresh less once a month, or can we use a cheaper storage, right? So yeah, all those things will help you basically to drive the cost down. Hire smarter than you. Again, it might sound obvious, but in a hypergrowth company, you don't have time to learn on the job. You remember the guy firefighting, the dog ears, and the VC? So it's not Bob's fault, right? It's just that, yeah, the data guy was just doing his best and learning Spark on the job in 2 days, right? So a df.show, 1 line of code, it's not, I mean, it's easily that you can forget such mistake. So invest into hiring process, technical talent acquisition is important, engineering branding, so doing engineering blogging is really nice, meetups. Please do not do any FANG-style interview. So, those FANG, like Facebook, they have like really conservative tech interview with algorithm DSL style, which is really difficult. But if you cannot pay like them, just adapt your process, please. Invest into onboarding process. You remember, again, my image with people like stuck in line. You have 25 Bob coming each month. So automate as you can. Access management, documentation, reproducible development environment. This is often like completely underrated. A good rule of thumb is that if your new hire is capable of doing a change into production that is merged in the first week, you're good, okay? And that's a good challenge. And I've seen company aiming for the first day. So putting a change in production, a small change in production, on the first day. And that's pushed the whole team to think, okay, how can we automate his access? Can we put some script on his laptop so that he has everything ready? Our documentation is up to date. Is that repository README still up to date? So it's forced everybody to basically push the things together so that people get onboarded faster. Don't hesitate to ask for external help. So hiring process is really hard and long. But you can hire like freelance for like a Spark training or setting up some baseline, because again, if you don't set up those baseline, it can go really sideways pretty quickly, our trainings. So what should you hire in the data team? Any guess? So the point is, and by the way, this meme, this almost 1 million view now on LinkedIn. So I don't know what I'm doing with my life. Probably just doing memes, which should be fine. But the point is, keep a good ratio of data engineers. Don't let your data engineer die under Velociraptor. So you can stack and hire data scientists or data analysts for your business case. But if your foundation of data isn't right, they will just spend time either doing data engineer, and that's not their main core skill set, or they will just queue to the data engineering and the data system. So the point is, to this ratio is still wrong because hiring data engineer is hard, and people tend to disregard good data engineering foundation. So find a good ratio. I would say, like in the example I gave with 300 people company, a good ratio is 1 data engineer per data scientist or data analyst. Of course, this ratio is really opinionated. It will evolve depending on your size of your company, but keep in mind this ratio. It's really, really important. Tip number 3, enable data self-service. Oh no, here comes the data mesh thingy. Are people comfortable with data mesh concept? Raise your hand if you are. Okay, some of them. So data mesh has been like a new movement in terms of data organization structure, where instead of having a central team, that does everything, you start to have a decentralized team. So your data engineer could live at the product team. But you still need to have a central team to maintain certain infrastructure assets, like cloud data warehouse, for example. And the problem with that mindset is that people think, okay, we need to decentralize. You actually just need to find the right level of decentralization that work for you. And so some tip, as I just said, like start with like a data platform team, for example. So that will manage like the core data products. So it can be a cloud data warehouse, it can be a framework for data processing. Basically, the goal here is that instead of saying, okay, there is a request, I'm doing this data pipeline, and I'm providing the data asset. No, I'm going to provide a framework so that other data citizens can do their pipeline themselves, right? So I lower the technical barrier to entry. I don't know if you heard about dbt, for example, that's enabled to schedule SQL pipeline. dbt is actually a framework to basically lower the technical entry to other data citizens. Another thing that's working really nice in such a setup is inner source. So inner source is basically having a view on your product that any other team can contribute. So there is this weird thing when you start to have a data platform team that they're going to build framework, but they're not going to use it. Maybe they're going to have like some tests or basic tests with those frameworks to make everything sure that's working, but they're not going to use it on a daily basis. And as I said, like the data engineer might live in another team and maybe has some skill set actually to contribute to that framework. So having like good documentation on such framework and an open mind to say, hey, I know you've been requesting different features, but actually you can contribute to that framework too. We still own the product, the roadmap, and so on, but we are happy to review and support you on any feature that you want to contribute. And that works really well because, as I said, like sometimes the responsibility when you start to decentralize is a bit blurry, right? What happens if something goes wrong? Is it the data platform team which is responsible? Or is it the data engineer that used that framework in a bad way that is responsible, right? But having this mindset of inner source is really great. Limit what your user can do. Again, a lot of Bob, right? So maybe they shouldn't even write a df.show somewhere. So if you give them too much freedom, it will be the Wild West. So what do? You restrict what they can do. But if you restrict too much, this will be the Wild West too, because shadow IT is a thing. So, and actually, this is even worse, because people tend to not contact you. They will do worse workarounds, because if you say, no, we cannot do this, and say, okay, I have this screaming business on my desk, I need to find a solution. So usually the mindset I do is that now I'm just contacting the person to say, hey, I cannot give you, I'm gonna give you more freedom, but with great power comes great responsibility. So I make sure to communicate that, yeah, for sure you can do it, but there is a lot of danger. If there is some problem, you're on your own because you're going sideways, right? But I'm happy to support and give you the access. So I think having this mindset is better because then people are coming back to you in more honest feeling if something goes wrong and you can work together. Be close to your user, so please treat data platform as any other product that you may have as an app, and hire a product owner, please. And those ones are really hard to find, like a data product owner. There is this debate, like, is a standard product owner good enough for a data platform team? Yeah, sure, but if someone has a background in data, that's even better. Finally, pushback ownership. So visibility on cost, ownership on budget. Again, if you show to Bob, it's basically link it to the baseline, show to Bob, hey, your 10 data pipeline is costing like more than 1,500 euro. Are you sure about this? It's your budget, it's taken from your team's budget. And you say, maybe I should do something. And believe me, I did multiple times this wall of shame where I have like the most expensive jobs that I sent on a weekly base, right? Saying, here is the user with the most expensive job. And I don't say anything. I just give that as a visibility. And believe me, this wall of shame is changing every week because no one wants to be on that wall of shame. Of course, it's not a blame game, right? There is always trust in my teammates, but you get the point. Tip number 4, buy versus build. So buy versus build is actually evaluating the time to market versus your technical debt. So there is no problem to buy off-the-shelf tools that does a couple of things for you, and especially if you're like in hypergrowth and you don't have the team yet to do things like in-house, but please evaluate like your locking risk and your agility to move out. I think like the best data team today is the one that can actually adapt to new change or technology or framework fast. I'm not saying that you should follow always the hype. No, that's not the case. But if you look at the ecosystem of data tools, it's really crazy how it's been evolving these past 5 years. And if you basically evaluate this every time you consider an off-the-shelf solution, I think it's going to save you money after for migration. So buying off-the-shelf tool can be a quick win, but it can cost you more after to get out. Building in-house products is also expensive, of course, with the maintenance, but more flexibility. Everything can cost billions and billions. Just please keep in mind this balance. Promote knowledge sharing. So yeah, sharing is caring. Guilds and tribes. So basically having guilds like data science guild, data engineering guild that bring people per function is really useful, where you can talk about those things. Hey, people, don't put a df.show in production, please, because yada, 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 right? And often those guilds and tribes, it's really more open. They don't have that much pressure from business. Sometimes a problem to contribute to those guilds. I think that should be part of some KPI from people to please contribute to the guild in any way. But yeah, that works well. Foundation matters. Often in data in general, we tend to skip software engineering best practice. Data modeling is also often forget because we have so much tools, right, today that it's already a struggle if you start a new data stack that you tend to forget those baseline. Blog, newsletter, make writing an habit. So I'm not talking about like external blog. You can do that, but start with like internal blog and internal newsletter. Remember, 25 Bob coming each month. Those Bob has no clue of what your team is doing. So if you have an habit of writing weekly newsletter, that really helps to be aware of what's going on, get to know your users, say, oh, you're going to develop that, maybe, So it's also really useful for leadership because they're being in the onboarding process. They have so much to take care of in such a hyper-growth situation. If you have a weekly newsletter to bring things that you're doing and some KPI, that's really nice. And also the writing as an external blog, it's really nice for engineering branding and it just attract talents. Hackathon is also nice. Internal hackathon, you don't need to be crazy. It brings people together. Don't expect too much output, but it's nice because they have the opportunity to not look at their ticket system, right? And just think outside. And even if it's like, far disconnected from the production and from reality, it's nice to just zoom out. I do a lot of side projects. I mean, I list some of them. And it always brings like some different view when I get into the company I'm working. Even if some things are not directly applicable, it's nice to just zoom out and try something different. Okay, so scaling data before scaling your data team. So first, know your data. Hire smarter than you. Keep a good ratio of data engineers, please. Don't let them die under the Velociraptor. Enable data self-service, but you don't need to be crazy in terms of decentralization. Buy versus build, and promote knowledge sharing. So yeah, every small problem can be a big problem at scale. Remember the dog years and the short time. So another small problem that you can easily solve is subscribe to my YouTube channel. That being said, so I'll be at the Qualys conference in New Orleans. It's the analytics conference organized by DBT. I'm not going to speak there. I'm going to be as a reporter and interview data experts. I have a bunch of interview planned. So if you want backstage gossip on what's happening in data, it's really the place to follow. Thanks. Any question?
Yeah, thank you so much. Thank you. I think it was very entertaining, yeah, with all the gifts and everything. So, yeah, who has questions? Let's do the lady first.
Okay, so starting with a comment that even though it has been apparently structured for the hyper-grow kind of small companies, I really see some parallels to the big ones where I am, where, for example, at the GBS Center, given the current turnover, especially in the IT jobs, we are having like hundreds of bobs monthly, right? So that's not only for small companies, it may really get to other ones as well. Question would be to this data engineer to data scientist ratio, like, so what assumptions actually you have taken to get this one-to-one? Because I've seen some pretty effective projects being done even with like 1 to 4.
So there is a huge problem in terms of definition here, both in data science and in data engineer. I have also a blog about this. Here comes a photo with my multiple me. That's where that photo is coming from. But the bottom line is really depending on what's your definition. So I think you can have data science which has, coming from software engineering world and have like good engineering practice, and then your ratio might evolve, okay? So what I'm considering here is that data science that has, not really a strong software engineering background, right? It's more oriented to analytics or machine learning, and data analysis basically kind of the same. So in that context, you need best practice because you will accumulate a lot of technical depth along the way. So I've been also asked, like, what's the first data hire that you would give? I would say a data analyst, right? Builds things that don't scale. That's fine. But then at a certain point, like, really keep this ratio, especially for big company. There is an inflection point where you cannot afford to have more data analysts. And once your data maturity is over there in terms of engineering foundation, then basically the data science, the analyst or hiring will follow just fine.
All right.
Does that answer your question? Yeah.
Okay, so I think there were a couple of hands. I don't know who was. Okay.
Hi, Mehdi. Thanks a lot for the insightful presentation. This is something I think even at our company we definitely can relate to, especially the data self-service, knowledge sharing, and also like the transformation into like different architectures. So my question was, I know that you did mention the product owner, right? The importance of a data product owner. So I was just curious to know, like, especially compared to startups and scale-ups, when it comes to collaboration between business, right? And then the people who actually work on building the solutions, like, for example, data engineering, data scientists. So how does that collaboration look like? Because I know, so I'm just curious to hear your thoughts, because you know, it's a lot of the times I think conventionally requirements were pushed to technical people rather than pushing the problem itself.
Yeah.
So I'm curious to know, like, because that I guess also gives more leverage to some of the standards and practices that you mentioned, in terms of, just like investing time in building those standards and practices, rather than just like firefighting, like you said,
Yeah. But so it's a good point. Like, I also worked like in big corporate, one of the biggest insurance company in the world. And it's true that in tech company and scale up, you have more communication between product in tech, right? But it's still data is still not considered as part of it. So you would have like trifecta, project manager, product owner, and an engineer per product. But data is always out of the scope. It's not still embedded. Like, some companies start to do it. They start to talk more about software data engineer rather just data engineer. And so in that sense, you end up with a data team that is still separate in silo. And the product owner here is really needed because your stakeholder is so wide in terms of a company. It can be software engineer, backend developer. It can be business or data analyst. So yeah, that's why I think like a product owner can really help to basically try to prioritize what's the most important thing. But it's no matter if it's a tech company or big corporates, I've seen it's always silos is still there.
Right, yeah.
I think we are a little bit short of time. Maybe you guys can, interact later. There's going to be a big lunch break. And I think you can fill it up with talking to a lot of interesting people and getting the expertise. Sorry for that. I have to cut short because we have a next speaker. And thank you so much, Mehdi. It was really wonderful. Thank you.